Hello everyone. So in today's video, we will solve this log equation. Now this equation has three log terms. So the first log term is log of 7x plus 5 to the base 8 minus then log of x minus 10 to the base 8. And then on the other side of the equation, we have log of x plus 2 to the base 8. Now in this equation, the variable is x, which is in all three log terms. Now the next thing we analyze is the bases of these log terms. Now all three log terms have the same base 8. So that means we can combine them using various laws of log. Now on the left side, these two log terms are being subtracted. So we can combine them using the quotient law of log. Quotient law of log. So as per this law, so if I have to do m to the base a minus log of n to the base a, so we can combine these two log terms into a single log term with the same base, and we can divide m by n. So this is the quotient law of log. So we can use this law for these two terms on the left side of our equation because they have the same base. So our first step is log of the base 8. So 7x plus 5 over x minus 10 equals, and the right side stays the same. Now we see that both sides of the equation have a log term and with the same base. We can get rid of the logs here because the logs have the same base, and we can rewrite our step as just the terms. So 7x plus 5 over x minus 10 equals x plus 2. Now that we have gotten rid of the logs, we can just solve it like a regular algebraic equation to isolate the variable x. So the first step is to cross multiply the denominator. So we get 7x plus 5 equals, and we multiply x plus 2 by x minus 10. So we use the parentheses to separate the terms from each other. We can use FOIL to distribute the terms on the right side of this equation. Now the left side stays the same. So we get x times x, which is x squared. X times negative 10 is negative 10x. Then 2 times x, which is 2x. And then 2 times negative 10 is negative 20. Now we can identify and combine like terms. So we get 7x plus 5 equals x squared minus 8x minus 20. So now we have a quadratic equation. So we can move all terms to the right side of the equation and set the equation equal to 0. So first we can subtract 7x from both sides so that we can gather and combine the x terms. So the 7x's on the left side cancel each other out. So we get 5 equals x squared negative 15x minus 20. We can subtract 5 from both sides. So I'll write it here first. So 5 equals x squared minus 15x minus 20. So if we subtract 5 from both sides, the 5 on the left side cancel each other out. So we are left with x squared minus 15x minus 25. Now this is a quadratic equation. We can use quadratic formula. A is equal to 1, b is equal to negative 15, and c equals negative 25. So if you remember, a, b and c represent the coefficients of the x square, x and the number terms. So we can write the quadratic formula. So the quadratic formula looks something like this. Square minus 4ac over 2a. We can sub in the values of a, b and c. So b is negative 15. So minus negative 15 plus minus and then negative 15 squared minus 4 times 1 times negative 25 over 2 times 1. X equals 15. So minus negative 15 becomes positive 15 plus minus and then square of negative 15 is 225 and then 4 times negative 25 is negative 100. Since it's negative 4, it will become positive 100. Because we have to do negative 4 times 1, which is negative 4, and negative 4 times negative 25 is positive 100 over 2. We can simplify. So 15 plus minus square root of 325 over 2. So I added 225 and 100. Now 325 is not a perfect square, but we can simplify it. X equals 15 plus minus. Now if we break down 325 into its prime factors, so it's 5 times 5 times 13. And I figured that out using my calculator over 2. Now if I have to simplify this, so I get 15 plus minus. So a 5 comes out of the square root and we are left with just 13 under the square root. So the two cases are, so one is positive, the other one is negative. So the positive one is x equals 15 plus 5 square root of 13 over 2. And the other one is x equals 15 minus 5 square root of 13 over 2. So these are the two solutions. So now we can use our calculator to evaluate it, just to get a sense of what these values are in decimal form. The first answer I got, so when I simplify, so I got this as negative 1.51. And if I evaluate this expression, so I got 16.51. I have to check if any of them are extraneous roots. This negative x value won't work for the log of x minus 10 to the base 8. So for x equals negative 1.51, which is the second case, so log of base 8, and then if I input x as negative 1.51 minus 10, so this will become log of base 8 negative 11.51. And this is an invalid term because log doesn't exist for a negative number. So we know that this solution is invalid. Now we have to check for the second solution. Now 16.51 will work for all three log terms because it won't make any of the log terms a negative term. So that's why the only valid solution in this case in exact form is x equals 15 plus 5 square root 13 over 2, and in the rounded form it will be 16.51. So if you find this video useful, please share it, like it and subscribe to my channel. Thank you very much and have a nice day. Bye.